So we have an idea of what happens to a function when you add or subtract numbers to it, and when you have a negative in there. So we have an idea, but you should have written this on page 3 in your notes yesterday, right? Okay, if you haven't yet, hurry and write the titles of each of the columns. Oh, and this is also section 5.1. So I skipped module 4 to module 5. Yes. So the first function that we're going to look at is y equals x squared plus 5. And what we like to refer to as the parent function is y equals x squared. So what I'd like you to do is predict what will happen from the parent function to this x squared plus 5. What do you think will happen to the graph? Okay, will it go left, right, up, down? Will it be flipped? So predict what will happen, and then we will find out what really happens. All right, so raise your hand if you made a prediction of what you think will happen. Yes? Okay. So let's, with our calculators, from the home screen, we're going to hit B to graph. If anything's on there, we're going to clear it by hitting menu 1-4 to delete everything.
How do you
Menu 4-5. Okay, if your window's off, to center it is menu 4-5, and that's also up here on my wall. Okay, how do I enter a new function? Tab. Okay, so let's enter the parent function of x squared so we see, okay, that's a parabola at 0, 0. We learned about those all last year. Okay, now let's enter the new one, so hit tab, and let's enter x squared plus 5. What happened to it?
Went up 5.
Shifted up 5. Okay, so who was correct on their prediction? Awesome. Okay, so prediction was whatever you put. It shifted up 5. All right, let's do another one. What if I put x plus 5 in the parentheses? Spencer, you're right over here. So if I put x plus 5 in the parentheses, I want you to predict, don't graph it yet. Predict what you think will happen first. Then after you predict, then let's graph that. So if you go parenthesis x plus 5, arrow out of the parenthesis, and then hit x squared, so that it looks exactly like we want it to. Okay, so what happened there? Shifted left 5. Is anyone correct on that prediction? Good job, Hope. So this shifted left 5. Okay. What about, let's do this one. Y equals a negative square root of x minus 3. Okay, and the parent function is just the square root of x. So predict what you think will happen from the parent function. What do you think will happen with that negative and the minus 3 that's under the square root? So make a prediction, and then clear everything and graph those two after you've made the prediction. So after you have square root of x, make sure on the second one you do the negative first. Square root, oops. What did I do wrong? Okay, so negative control x squared. And make sure that x minus 3 is in the square root symbol or under. Enter. Okay, so what happened there? Flipped and write 3. Okay, so anyone right on that prediction? Good job. Okay, so we flipped and then write 3. Okay, so let's do another one. What if we have 3 in front of it? Square root of x minus 1 is under the square root and plus 2 on the outside. Okay, this is still square root of x is the parent function. Predict what you think will happen. What do you think that 3 will do? What will the minus 1 do and the plus 2? So make a prediction. And after you've written that down, then graph it. Make sure the plus 2, you arrow out of the square root symbol for the plus 2. Bless you. So once we enter that, graph it. Okay, what happened here? What do you think the 3 did to the graph? What? Okay, made it steeper. Good. What about the minus 1? Right 1 and the 2? Up 2. So we're going to say it's steeper. Right 1, up 2. Okay, let's do one last one, and let's see if we can get this one correct when we predict. So 1/2 times the absolute value of x plus 4. And the parent function is just the absolute value of x. Okay, so I want you to predict what you think will happen. No matter what the shape of the graph is, just predict what you think will happen with the 1/2, multiplying that, and the plus 4. Yeah.
How do you do the 1/2?
Just go 1 divided by 2. So just enter that.
Okay.
You make sure on here they get 20 points if they had either they had a misleading graph and then they corrected it so it wasn't misleading, or Sorry. What do you predict will happen?
Less steep and smaller.
Less steep, move up 4? What did you say?
Smaller, less steep.
Smaller, okay. All right, so let's go ahead and graph. Let's clear all of this. You guys probably have already done this. So if we enter absolute value, it's next to the 9. Right there. So that's the absolute value of x. That's the parent function. So then if we do 1/2 or 0.5, absolute value of x, and on the outside we go -4.
It's plus 4.
Oh, I said plus. Sorry. Oh, I posted the wrong thing. Okay. Thank you. Okay, so what ended up happening? Were we right? Yep. So it's going to move it. So it made it less steep and up 4. So what is the difference between this one and this one with the +5? Yeah, so it's either in the squared, right here it's in the squared, this is not part of the squared, right? And same with the square root. This is in the square root symbol, which is why it went left and right, versus this number on the outside is what shifted it up. So if it's in the operation symbol, whether it be a squared, square root, or an absolute value, then it goes left and right. And what do you notice? This is +5, but where did it go? Left. This is -1, but it went right 1. Okay? So your horizontal shift is the opposite sign. Always, with every function. Vertical shift is exactly what it is. What if on this one I had 1/2 x plus 4 in the absolute value? How would that? Would that still go up 4? No, that is going to shift it left 4 because it's in the actual operation of the function, okay? All right, so let's write these rules down under the table. You guys have in your notes? I want you to write this. So transformation rules, we're going to write. Okay, so if it's a negative in front of it, and that means it's going to reflect over the x-axis, so it'll flip it. If it's adding or subtracting in the operation symbol, so like here if we had a squared, this is going to be a horizontal shift. Okay, but there's a saying that I want you to remember, and that's if it lies inside. Who said that? Connor, did you say that? Who?
Say what?
Finish my phrase here. Okay, if it lies inside, it lies. Which means if it lies inside the operation symbol, it's lying to you. So it's not the sign that it is. Okay? So here, if it was -3, the 3 is lying, it's really going to go right 3. Okay? So if it lies inside the operation symbol, it's lying. Okay, next one. Let's do f of x. If you're adding k for any number, this is a vertical shift. And this is the exact sign it is. So if it's +5, it goes up 5. If it's -3, it goes down 3. Okay, the other thing. Let's stop, Spencer. If you have a fraction, okay? If you have a fraction multiplying to your x, or to the operation symbol, if the fraction is 0, the graph, we can say, gets wider, or something like that, it'll get less steep. Say if it's a line, or like the square root one. So depending on what the shape of it is, it'll get wider or it will be less steep, okay? Then if the number is greater than 1, the graph gets steep, depending on what.
Have a little, so we can do like, for example,